Okay, so today we're going to talk about rational functions of the form ax plus b over dx plus c. I already spoke about the theory behind what makes an asymptote and what makes a y-intercept and zeros and things like that. So for this one, I'll kind of just cut straight to the chase, and we'll go over just two things: how to take a equation and build a graph, and then how to take a graph and build an equation. Okay, so I'll just go straight into a few examples. Example 1. Graph. Let's go with something like f of x is equal to 3x minus 1 over 4x plus 2. And there's some guys working outside my door. Let me close the window because they're making some noise. Okay, so there's three things that you're going to want in order to graph this, and you should be able to graph it with only these three pieces of information. Alright, and one of them is the vertical asymptote, and the other is the horizontal asymptote, and then the other will be the y-intercept. And so there's actually a pretty interesting set of formulas. The vertical asymptote is again where the denominator is supposed to not equal 0, and in this case it's going to be a negative 2/4. So again, you just say 0 cannot equal 4x minus 2, plus 2, and then you subtract 2 and you divide by 4, and so in the end the vertical asymptote is a negative 2, because I subtracted 2 and then I divided by 4, negative 2/4. That would be the vertical asymptote. Alright, so in a way, if we look at the form up here, it's c divided by d negative. So the vertical asymptote is a negative c over d. It's always going to be that way, because today we're talking about rational functions of this form, and they're only going to appear in this form. So the horizontal asymptote, we'll now figure out the horizontal asymptote. Now for the horizontal asymptote, the idea is, there we go. The idea is that it's actually always going to be the ratio of these two numbers right here, 3 over 4. So the horizontal asymptote is going to be a over d. A over d. Okay? And I'm not going to explain the theory behind it, but it's you can just start plugging in large numbers here, large positive numbers and large negative numbers, and you'll see that this function always achieves a value very close to 3/4. It achieves a value very close to 3/4. Let's see if these numbers basically become they don't make any difference anymore. as soon as we get into the large x values and the large y values. And so we've got a vertical asymptote. And so my horizontal asymptote is 3/4. If this number happens to be negative, then it's a negative 3/4. If this number happens to be negative, then it's a negative 3/4. If they're both negative, then it's a positive 3/4. Okay? So it's the ratio of those numbers. Now the y-intercept. The y-intercept is where we let x equal 0. And it turns out it's very convenient. If I let x equal 0 here and here, then these two numbers actually disappear from the equation, and these are the only important ones. And so the y-intercept in this case is negative 1/2. All right? And so let's go over that again. Oh, wait, let me write down this. It's b over c. And so these are our three equations here. The vertical asymptote is a negative c over d. Okay? A negative c over d. Then the horizontal asymptote is a 3/4. And then the y-intercept is a b over c. So you've got these three sort of combinations of numbers: the denominator, the coefficients here, and the constant terms here, that give you these three pieces of information: 1, 2, and 3. And now with this information, we can actually make a pretty good graph of this rational function. And so what I'll do is we'll remember these, and I'll make my graph down here. Let me come out a little bit. There we go. So I do know that I have a y-intercept at negative 1/2. All right. This being 1, this being 1, 1, 2, this is 3, negative 2. Then I got 1, 2, 3, negative 1, negative 2, negative 3. So I'm starting to build a graph. Now I've got a horizontal asymptote at 3/4. 3/4 is almost 1. So I'll go ahead and put my horizontal asymptote there at 3/4. Then I've got a vertical asymptote at negative 2/4. I'm going to reduce this to negative 1/2. So my vertical asymptote is also negative 1/2. So I've got a vertical asymptote here, like that. And now I can actually just make this graph, because remember, the graph always hugs the asymptotes, and it must pass through the y-intercept. So my graph is actually going to look like this here. And while we're at it, we could actually solve for the x-intercept as well. Yeah, let's actually get the x-intercept, because I believe some questions will ask that. So here we figured the y-intercept. Now let's figure the x-intercept. Remember, always to find the x-intercept, you set y equal to 0. So I'm going to take my function 0. The f of x up here is going to be a 0. Then I'm going to write my function next to it, 3x minus 1 divided by 4x plus 2. And so the x-intercept is now, what I'm going to do is I'm going to cross multiply to solve this. Or I'll basically take both sides of the equation and multiply by 4x plus 2. But since I have a 0 over here, this actually cancels out. Because the only way to get this side to equal 0 is if the numerator equals 0, and it doesn't matter what the denominator is. So the denominator actually becomes unimportant. All right, and so we end up with this equation. 0 is equal to 3x minus 1. And because this, remember, just cancels out. So if I solve for this, I get, remember, we're trying to find the x-intercept. I get a positive 1 over 3. Positive 1 over 3. Okay? And so that actually makes me think of another equation. The x-intercept. The x-intercept is actually always going to be a negative b divided by a. A negative b divided by a. And so we basically have all of the information that we need in order to, let's actually, it's a positive 1/3. Positive 1/3 is right there. So if I fill in my graph, I have my x-intercept, negative b over a. My y-intercept is a negative 1/2. My horizontal intercept, oh wait, sorry, let me go back again. X-intercept, negative b over a. Y-intercept is a b over c. X, or horizontal asymptote, is an a over d, and a vertical asymptote is a negative c over d. And these are actually pretty quick and easy ways to find all of the information about the graph, and then you can graph them like that. You just have to make sure that you hug the asymptotes here and here, and that you go through the appropriate x and y intercepts. And so there is the graph of this function here. Now before I move on, I'll talk about the domain. The domain is x is a real number such that x cannot be, the only x value that we cannot achieve is a negative 1/2. Okay, and the range is y is a real number such that y cannot be, the only y value that we can't achieve was right here at 3/4. And so there we have the domain, the range, the graph, the x-intercept, the y-intercept, the horizontal asymptote, and the vertical asymptote. All right? And we started with that equation there. Now what I'll do is I'll go the other direction. I'll start with a description of a graph, and then we'll try and build the equation. Okay? And so basically you're going to be kind of using this information here to go backwards and find the equation. All right, so let's see. Usually these appear in the following manner. They either give you a graph or a description. Okay, I'll do the description. So write an equation of the following function. Alright, so it has an x-intercept of -4. It has a y-intercept of -2, and it has a vertical asymptote of 2. the street cleaners going by this other window. Let me close this. Okay, so these aren't as difficult as they seem they might be. First of all, let's recall our equations. The x-intercept is it's going to have to be a negative b over a. Okay. The y-intercept is going to have to be a b over c. And the vertical asymptote is going to have to be a negative c over d. Alright? So I need a negative b over a b over c, and a negative c over d. So notice in this description I've got an A, a B, a C, and a D. So in reality, if I can kind of make combinations of these numbers so that they equal this. So in reality, I just basically need a negative 4 to be equal to a negative b over a. I need a negative 2 to be equal to a b over c, and I need a positive 2 to be equal to a negative c over d. And then once I start kind of figuring all of these things out, I kind of put them in my my original equation up here. And so the way to make, I'll just start with this one. The way to make this a negative 4, I'm going to have to write a negative 4 as a 4 over 1. And then if I make it negative, then it's a negative 4. So in this case, my b is 4 and my a is 1. Okay, so I've got two things now. And now what I do is I take this information and I bring it over to the next one. Okay, notice I have a b and an a. If I know that my b must be 4, then I can take my b and plug it into here, and then I can figure out what my c has to be. Alright, so my c value is unknown, but I know that my b value must be 4 from the previous equation. So if I make that 4, how do I find a c value here? Well, it looks like my c value must be negative 2, because a 4 divided by a negative 2 is equal to a negative 2. Alright? And so now what I've discovered is my c value is a negative 2. And now, again, I just take this information and I bring it over here. And if I say that 2 is equal to a negative 2 divided by what? It looks like my d value must be positive 1. Okay? And so you can kind of figure out what these are. The first one you get to make up any way you want. Then the seconds, just they fall into place as it goes. Alright? And you've got to practice this a few times, and it just starts to work. And so now my function is f of x is equal to a, which in this case is 1, x over x. My a value goes here. My d value goes here, it's also 1. My c value goes here, right here, -2, and my b value goes here, +4. And so this is my function. Remember, we have a 1 here and a 1 there. Alright? And so, there we have it. Maybe I'll do one more of these, and you can watch it if you need it. Let's see. Write an equation so that the following are true. Okay, so what I'm going to say is I'm going to have an x-intercept of -3. I'm going to have a y-intercept of 2/3. I'm going to put some fractions into this one. And I'm going to have a horizontal asymptote of, let's go with -2, no, we'll go with -4/5. Okay, so if my x-intercept of -3, remember the x-intercept must be equal to a -b/a. Alright, so I'm going to start with a -3 needs to equal a -b/a. And so that implies that b must be 3 and a must be 1. Okay, it's kind of a similar thing that I had before. Alright, because if I plug a 3 into here and a 1 into there, then it'll simplify down to a -3, which is what I want my x-intercept to be. Now I'm going to figure out the y-intercept. This was the x-intercept. This is the y-intercept. I know that the y-intercept must be 2/3. Okay? And the y-intercept needs to be equal to a b/c. Oops, b/c. I kind of messed that up there. But I do know that my b is already 3. Okay? And so I get 2/3 is equal to 3/c. And now in this one, it might not be very clear for you to figure out what the c value actually is. So what you'll want to do is cross multiply. Cross multiply, you actually want to just solve for c in this case. So 3 times 3 is 9, and 2 times c is 2c. So I get 9 is equal to 2c. Then I divide by 2 and divide by 2. In this case, the c value must be 9/2, or 4.5. Alright? So I've got a b value, an a value, and a c value right now. Okay? Now my horizontal asymptote. Now all I need is the d value. And my horizontal asymptote, or we'll figure out the horizontal asymptote now. The horizontal asymptote must be a -4/5. And the horizontal asymptote is always equal to, if I check my equations over here, the horizontal asymptote is always equal to an a/d. Alright? And so I'd say that it is equal to a/d, and I already know from back over here that my a value must be 1. So I'm going to say a -4/5 is equal to a 1/d, and now I can solve for d with cross multiplication as well. So even if you have fractions in here, it's not a problem because of the magical magicalness of cross multiplication. And so you can cross multiply like this. Negative 4d is equal to 5 times 1, or just 5. Solving for d, I get divide by a negative 4, and divide by a negative 4. I get d is equal to a negative 5/4. Alright, and so maybe right here I'll write my function f of x is equal to, now my a value goes here, my b value, my c value, and d. It's alphabetical, a, b, c, d. Alright, so my a value is 1. My b value is a positive 3. My c value is a 9/2. And my d value is a negative 5/4. This equation actually has the following properties. It has an x-intercept at negative 3. It has a y-intercept at 2/3. And it has a horizontal asymptote of negative 4/5. Pretty good, eh? And so there we have it. Now, the textbook actually is going to have a slightly different function than this. Let me just go and do one last thing here. See if I've got some extra space without having to use a brand new piece of paper. Here we go. Notice how we've got a 1x plus 3 over 9/2 x minus 5/4 as our function. Okay, this is correct. Oop, there, sorry. I just wrote down what we just got. This is actually correct, but if you want to check your result in the back of the textbook, they're going to actually have something slightly different, because I believe they don't like to have fractions here. And so in order to eliminate these fractions, what I'm going to have to do is multiply this function by 4 over 4. I multiply it by the largest denominator here. Actually, no, I don't multiply it by the largest. I multiply it by the common denominator of all of the denominators. Okay? Then what I've got is I'm multiplying it by 4 over 4, which means I'm actually not changing it, because I'm just multiplying it by 1. And when you multiply by 1, you don't change the value of anything. But I'm multiplying by a fancy one called 4 over 4. Now this 4 distributes into here, and this 4 distributes into here, according to the rules of multiplying two fractions. And so if I distribute this 4 into here, it's 4x plus 12. 4x plus 12. And if I distribute this 4 into here, half of the 4 is going to cancel with this 2, leaving me 2 left. That 2 left will multiply with the 9, leaving me 18x. And now this 4 will actually cancel completely with that 4, and it'll leave me a 5. And so this is actually what you will probably see in the back of your textbook as the correct answer, even though what we have here is correct as well, and I won't count off if you write this, but I also won't count off if you write this, because these are actually correct, both of them. Okay.